Welcome back. Let's do this. Today we're going to talk about inequalities, solving and graphing. There's 4 little guidelines for this class that we're going to use when we are graphing our inequalities. The first one, remember old school stuff, when you are multiplying or dividing by a negative in an inequality, you must switch the direction of the inequality sign. When graphing, if you have a less than or a greater than symbol, we are going to graph with an open circle because it does not include that value. If it is less than or equal to or greater than or equal to, then we do color that in because it does include the value. Not equal, obviously it has to be an open circle because it does not include the value. Third tip, if x goes first in your inequality, then your graph is going to point in the same direction as your inequality sign. And finally, when you are graphing this on a number line, I need you to put the number 0 and any other solutions that you have. Okay, so those are some guidelines. We're always going to do for all real numbers unless anything is specified, such as if I say solve with respect to integers only or something like that. Okay, so here we go. Here's a couple simple ones just to refresh your memory before we get into compound inequalities. Whenever you are solving, remember if x goes first, you will graph in the same direction. So I'm going to do this one just by subtracting 2x from both sides. And that's going to give us 2x plus 9 is greater than or equal to 21. Subtract 9 from both sides. It's just like solving any other equation. And that's going to give us 12. Divide both sides by 2. And we're going to get x is greater than or equal to 6. So that's the solving part. To graph it, all we need to do is create our own number line. And as it says in your little tips or guidelines, I want 0 and the number. Do they have to be numbers or tick marks in between? No, you don't. So since this is greater than or equal to 6, since x goes first, notice how this is pointing to the right. We're going to graph to the right. Now notice how I did mine above the graph and not on the graph. There's a reason I do it. You'll see it in a little bit. This is how we're going to do it for this class. Okay, so go ahead, pause the video, try the next one on your own. Press play when you're ready. Here we go. First thing, subtract 12 from both sides. And we're going to get a negative 5x is greater than a 10. Divide both sides by a negative 5. Remember that special note at the beginning. X is less than a negative 2. Because we have to switch the direction of the sign when we multiply or divide by a negative. So here's our number line. Here's our 0, here's our negative 2, and x is less than, so we have an open circle, and we are going to point to the left because that one points to the left. Okay, so that takes us to regular solving inequalities. I'm going to pause you for a second. We'll be right back. So compound inequalities. Compound inequalities is when we're going to have 2 different situations that we're working with. In this case, we're going to be talking about and or statements. So an and statement is also known as an intersection, and it is also used with this symbol. Okay, so this symbol, an upside down U, means intersection. Now the key to and statements is they must be true for both. Okay, both inequalities must be true to satisfy an and statement. Now the other type of compound inequality we're going to work with is an or statement, which is also known as a union and uses a big U for a symbol, easy to remember, a U for union, upside down U for intersection. Now the thing with an or statement is only one needs to be true. Okay, so here we go. Number 3. The first thing we want to do is look at this, and since we have two inequality symbols on the side of a expression, that means this is an AND statement, okay? Or must use the word or the union symbol. And could say and, it could use the intersection symbol, or it could actually just be a compound inequality where we have two inequality symbols in one. So to solve a compound inequality, we do the same thing as any solving equation, except for when we subtract 5, we're going to subtract 5 from all three parts. So this is going to give us a negative 9 is less than or equal to 3x, which is less than 6. So now we have to divide everything by 3. That's going to give us a negative 3 is less than or equal to x, which is less than 2. So this is our compound inequality. To graph this, we're going to have our negative 3, 0, and 2. And we need to split this up into a few parts. So first thing we're going to do is I'll graph negative 3 is less than or equal to x. Remember, if x comes first, you go in the same direction. But in this case, negative 3 comes first. So we're going to put an open or a closed circle above negative 3, and we need to point in the opposite direction because x does not come first. Okay, now we need to look at the other part of this inequality. X is less than 2. So we have an open circle above 2. Since x comes first, we point left because that's the direction, because x goes first. Now an AND statement needs to satisfy both. So we can break this up into three parts here. We can go just where we have a purple line, just where we have a green line, or we can go in the middle where we have both purple and green. So let's pick a few numbers. How about negative 10? Does negative 10 satisfy both? No, it does not. It is less than 2, but it is not greater than a negative 3. Let's pick something like a positive 10. Does 10 satisfy both? No, it doesn't, because it is not less than 2. Now let's pick something in the middle. How about 0? Does 0 satisfy both inequalities? Yes, it does. 0 is greater than or equal to a negative 3, and it is also less than 2. So when we have an AND statement, all you have to do is show me where it is true for both. So the red line on the third tier is technically your final answer. Okay? Number 4 is an OR statement. We're going to go back, and for OR statements, they have to be separated, so you just solve each one. For this one, we're just going to have 2x is greater than 8, so x is greater than 4. Or this one's going to give us a negative 4x is less than or equal to a negative 12, and x is greater than or equal to 3. Now remember, we have to change the direction of the signs. Now this is where things get a little fancy, and this is also why I use a three-tiered method, because we are going to have a special case happening here. So we have our 0, our 3, and our 4. X is greater than or equal to 3. X comes first, so we point in that direction. And then we have x is greater than 4. Open circle, point to the right. So now we have our final answer. So we only need to satisfy one of these to make it a true statement. So obviously nothing less than 3 is going to work. But what about 3? Does it satisfy one of the two inequalities? Yes, it does. 3 is greater than or equal to 3. How about 5? Yes, 5 satisfies both of them. What about 3.5? Yes, it satisfies one of them. And for an OR statement, you only need to satisfy one to make it true. So our final answer is anything greater than or equal to 3, because anything greater than or equal to 3, that includes 4. And since you only need one, that's all you need for this equation. So your final answer is x is greater than or equal to 3. So you have 4 left. Feel free to pause the video and give them a try. So let's finish these up. This is a union or an OR statement. So negative 2x is less than or equal to negative 6. So x is greater than or equal to 3. Subtract 4, 2x is less than 10, so x is less than 5. Number line 0, 3, and 5. X is greater than or equal to 3. X is less than 5. So what are we going to say? Remember, OR statements only need to be true for one. How about 10? Yes, it's true for the green line. It's greater than or equal to 3. How about a negative 10? Yes, it's true for anything less than 5 for the purple line. How about 4? It's true for both. Any number you can think of will be true. So this is another special example where we have all real numbers will work for this inequality because we are dealing with a union or an OR statement. Number 6 is an AND statement because it's intersection. So these we have to be true for both. So 2x is greater than or equal to 12. X is greater than or equal to 6. 6x is less than or equal to a negative 12. So x is less than or equal to a negative 2. Notice I didn't change the direction because of a negative because I didn't divide by a negative. So we have our number line. Negative 2, 0, 6. First one, x is greater than or equal to 6. X is less than or equal to a negative 2. And then we need to figure out which numbers are going to be true for both. Well, I ask you, can you think of any number that is both less than or equal to a negative 2 and greater than 6 at the same time? The answer is no, you can't. So if it's not possible, the answer is just no solution. Number 7. Number 7 is a not equal to. So we solve it just like any other equation. So you're going to subtract 7x, you're going to get 5x is not equal to 10, so x is not equal to 2. Number line 0, 2. Not equal to means any number except for 2 will work for this inequality. So all you have to do is put an open circle above your 2 and point in both directions because any other number will work. Finally, your last example is number 8, which is an intersection, an AND statement. So we're going to end up with a negative 4x is less than or equal to a negative 12. So x is greater than or equal to 3. This guy, 2x, is less than or equal to 6. So x is less than or equal to 3. Number line 0, 3. So let's think about this guy. First one, x is greater than or equal to 3. Next one, x is less than or equal to 3. This is an AND statement. What is the only number that is less than or equal to 3 and greater than or equal to 3 at the same time? The answer is 3. That concludes our lesson on solving and graphing inequalities and compound inequalities. Have any questions? You know where to find me. Have a good one.